Hello, and welcome back to the Cosmos Sleep Channel. Settle in softly, breathe deeply, and allow your entire body to gently unwind. Tonight, we begin a long, deep drift into the subtle, intricate, and endlessly mysterious universe within you. The human brain. Rest quietly and imagine this remarkable organ, protected in the quiet darkness of your skull, floating in a cushion of warm cerebrospinal fluid. It never stops. It never sleeps the way you do. Even now, as you settle deeper into the softness of your bed, billions of neurons communicate in delicate patterns of light. They do so gently, slowly, guiding your breath, shaping your thoughts, and subtly regulating the rhythms of your inner world. The brain works like a silent orchestra, each neuron playing its part without sound, without hesitation, without fatigue. As you sink into stillness, imagine those neurons glowing with a faint, tranquil radiance, drifting between firing and resting in a calm, almost celestial harmony. Science often calls the brain the most complex object in the known universe. But complexity does not mean chaos. Inside your mind, everything follows patterns, soft patterns, deep patterns, patterns that gently emerge and disappear, like waves rolling across the surface of a calm ocean. Though thoughts may feel scattered, the brain's internal logic remains stable, subtle, and beautifully organized. Even when you sleep, even when you dream, even when you drift into the deepest rest, the brain continues its silent, restorative choreography. Its networks unwind, reorganize, repair, and gently cleanse themselves. Tonight, as we explore the mysteries of this quiet universe, let yourself feel a deep sense of peace, knowing that your brain is designed for balance, for healing, and for renewal. With each breath, it gently resets, gently clears, and gently prepares you for a new day. One of the most enduring misconceptions about the brain is the idea that humans use only 10% of it. This myth, repeated softly across generations, has no scientific foundation. In truth, nearly every region of your brain is active, slowly, subtly, and consistently throughout your entire life. Even during sleep, neurons fire in delicate patterns, supporting memory, regulating emotions, restoring chemical balance, and guiding the slow drift through dream states. Your brain is not lazy or underutilized. It is profoundly efficient. Each region performs its task with quiet precision. Some areas rest, while others work, and then they gently trade places, never overwhelming the system. So as you lie here tonight, allow yourself to release the old idea of limitation. You are always using your brain. You are always alive with activity. You are far more capable than the myth suggests. Even the thought of using more of your brain becomes unnecessary when you understand how deeply interconnected each region already is. The frontal lobes gently regulate decision-making and planning. The parietal lobes quietly shape touch, space, and the awareness of your body. The occipital lobes rest at the back of your head, softly processing light, shadow, and color. The temporal lobes guide memory and emotion with a slow, subtle rhythm. And beneath them all, deeper structures like the hippocampus and amygdala drift through cycles of memory formation and emotional interpretation. Nothing is wasted. Nothing is idle. As you breathe slowly, imagine all of these regions glowing softly, coordinating with one another, like lanterns flickering along a quiet path in the night. They support you gently, continuously, with a level of precision that requires no conscious effort at all. As you drift a little deeper into this quiet journey, let your awareness settle softly on the gentle flow of communication inside your brain. Each neuron sends signals, not by force, but by the subtle movement of ions, drifting through tiny channels in the cell membrane. These electrical impulses rise and fall with delicate precision, like soft ripples moving through calm water. When a signal reaches the end of one neuron, it does not collide harshly with the next. Instead, it pauses in a narrow space, the synaptic cleft, where tiny chemical messengers float gently across. These messengers, called neurotransmitters, settle into receptors on the neighboring cell, guiding it to respond or to rest. Nothing about this process is loud. Nothing is rushed. Your thoughts, your awareness, your emotions, all of them rise from this slow, quiet exchange of energy. And as you breathe deeply now, you may begin to feel aligned with that gentle rhythm, drifting in harmony with your inner world. The beauty of this microscopic process lies in its coordination. Billions of neurons, each firing softly, create patterns that shape your experience of reality. Some networks energize when you focus, lighting up with subtle bursts of activity. Others awaken when you imagine, when you remember, when you dream. Some pathways quiet themselves when you rest, entering states of low activity that allow the brain to renew its strength. This constant ebb and flow is what makes consciousness feel fluid. Never rigid, never fixed, always unfolding. You do not feel individual neurons firing. You feel the overall harmony, the deep and tranquil hum of networks working together. Tonight, as you drift deeper into rest, imagine these networks gently dimming, like lanterns lowering their light, preparing your mind for a long, restorative night of calm awareness. When sleep begins to take hold, your brain transitions through stages that grow progressively slower and more peaceful. In the earliest stage, your senses gently loosen. Sounds feel softer. Light fades from importance, and your thoughts begin to drift. The brain waves shift from busy beta rhythms into smooth alpha waves, the gentle frequency associated with relaxation and inward focus. As you sink further, alpha gives way to theta waves, deep, slow oscillations that guide you into the first true layers of sleep. These waves are like long, slow breaths within your brain, expanding and contracting with rhythmic softness. During this time, the outside world begins to fade away, and the mind transitions into a dreamlike openness. You are not unconscious. You are simply drifting, resting, letting go. As theta waves deepen, your brain eventually descends into the slowest most restorative pattern of all, delta waves. Delta waves move like calm ocean swells, wide and unhurried. In this state, your body repairs tissues, restores energy, balances hormones, and strengthens the immune system. Meanwhile, your brain quietly consolidates memories, gently reshaping neural pathways to support learning and emotional clarity. This stage, known as slow wave sleep, is one of the most profound forms of rest the human body can experience. The mind becomes still. The body becomes heavy, and consciousness gently recedes into a serene, timeless space. These delta waves are nature's deepest lullaby, carrying you further into renewal with each slow oscillation. Deep within the resting brain, a quiet and essential cleaning process slowly begins to unfold. This is the glymphatic system, a gentle network of channels that expands during sleep. As you drift deeper into rest, the spaces between your brain cells widen ever so slightly, allowing cerebrospinal fluid to flow in with calm, steady pulses. This fluid washes through the neural landscape, clearing away the metabolic byproducts that accumulate during waking hours. Waste molecules like beta amyloid are slowly, quietly removed, carried along subtle currents that weave between the cells. It is a cleansing tide, unseen and unfelt, but profoundly important. Without this nightly rinse, the mind would become foggy, tired, weighed down by the residue of consciousness. Tonight, as your body unwinds, imagine this soft, internal river drifting gently through your brain, restoring clarity, freshness, and deep tranquility. The glymphatic system functions best during the deepest stages of sleep, when delta waves dominate the cortex and neural activity slows into long, sweeping cycles. The brain's energy demands drop, allowing more resources to shift toward restoration. Glial cells, the supportive caretakers of the nervous system, contract slightly to open broader channels for cleansing fluid. Astrocytes guide the movement of this fluid, while waste is funneled out toward the body's circulatory system. It is a slow, rhythmic process, unfolding like a peaceful nighttime tide. When you awaken after deep sleep, the sense of mental clarity you feel is not an illusion. It is the result of this meticulous, quiet housekeeping. The brain has been washed, refreshed, and prepared for another day of thought, emotion, and perception. This is why rest is sacred. It is why sleep is not a luxury, but a biological necessity. Memory, too, is shaped during sleep, gently, gradually, in soft layers that settle into place as the night unfolds. Throughout the day, your brain collects fragments of experience, sounds, emotions, images, ideas, conversations. Some of these remain vivid, some drift into the background, and some dissolve entirely. But during sleep, especially during slow wave and REM cycles, the brain sorts these fragments with careful attention. Important memories are strengthened, while unneeded details slowly fade. The hippocampus, deep within the temporal lobe, replays recent experiences in subtle patterns of activity. It sends these patterns outward to the cortex, where long-term memories quietly take root. This transfer of memory is not loud or conscious. It is soft, gentle, and guided by slow oscillations that ripple through the sleeping brain. During REM sleep, emotional memories rise to the surface, blending with imagination and forming dreams. During NREM sleep, especially in stages of deep delta waves, procedural skills are refined, knowledge becomes stable, and the brain's emotional centers find balance. This nightly reorganization is essential for learning, creativity, and mental well-being. Without it, thoughts would feel tangled, emotions would feel overwhelming, and memories would be fragile. As you continue to breathe deeply now, imagine your own memories drifting into place, settling softly like leaves resting on a still pond. Perception, the way you experience the world, is not a simple reflection of reality. It is a slow, intricate construction shaped by your brain. Even the act of seeing begins as gentle electrical signals drifting from the eyes into deeper regions of the cortex. The brain does not passively receive this information. It interprets it, filters it, and softly fills in gaps with patterns learned over a lifetime. Light enters your eyes as raw sensation, but by the time it becomes an image, it has already been touched by memory, expectation, and emotion. This process unfolds in layered waves, moving from the primary visual cortex to higher regions that add shape, depth, meaning, and familiarity. You are never simply seeing. You are quietly experiencing a delicate blend of the outer world and your inner world, woven together with remarkable subtlety. The same gentle construction happens with every sense. Sound enters as vibration, but the brain interprets it through networks shaped by past experiences. Touch begins as pressure or warmth, but the brain adds emotional tone and context. Even time itself is a perception, something the brain assembles moment by moment, influenced by attention, mood, and expectation. When you are relaxed, time feels slow, spacious, like a deep breath that never rushes. When you are anxious or overwhelmed, time seems to compress, slipping past too quickly. This fluid sense of time is not a flaw. It is a reflection of your brain's flexibility, its ability to drift gently between states of focus, rest, and imagination. Tonight, as you unwind, allow your perception of time to soften, to stretch, to expand into something calm and unhurried. Within the brain's quiet depths lies a remarkable power known as neuroplasticity, the ability to reorganize, reshape, and gently rewrite itself throughout your life. Every experience you have leaves a faint imprint on your neural pathways. When you learn something new, neurons form stronger connections. When you practice a skill, those pathways thicken and stabilize. When you stop using a memory or habit, its pathway becomes quieter, fading slowly like a trail no longer walked. Neuroplasticity is not rapid or dramatic. It is slow, subtle, and deeply patient. It allows the brain to adapt, to recover, to heal, and to grow, regardless of age. Even now, as you listen and drift deeper into rest, your brain is gently adjusting, forming new associations, rewiring small details, preparing you for tomorrow. This ongoing rewiring gives the brain an extraordinary resilience. After injury, it can form new pathways to bypass damaged regions. After emotional stress, it can create fresh circuits to support new habits and healthier responses. Even during sleep, neuroplasticity continues. Synapses strengthen or weaken based on your experiences from the day. It is a quiet sculpting, a nightly workshop where the brain refines its architecture. The idea that the brain is fixed or rigid is simply untrue. It is as flexible as water, as adaptable as a gentle tide. And this means that every night of rest, every moment of stillness, supports the ongoing journey of growth and renewal. Allow yourself to drift deeper, knowing that your brain is always capable of change, slowly, softly, and beautifully. Inside your brain, one of the most subtle yet essential networks remains quietly active at all times: the default mode network. This network gently hums in the background when your mind is not focused on a specific task. It lights up softly when you daydream, when your thoughts drift, when you reflect, and when you wander internally through memories or imagination. The default mode network acts as a bridge between your inner world and the outer world, weaving a sense of self, a continuous identity, and the quiet narrative of your thoughts. As you rest now, this network becomes especially calm, gently smoothing out the edges of your mental activity, helping your thoughts loosen and dissolve into softer forms. You may notice your mind drifting, circling, relaxing, and that gentle drift is this network settling into tranquility. When the brain enters deep rest, the default mode network becomes less active, making space for more restorative processes to unfold. This shift allows your mind to unwind, free from constant self-reflection and internal chatter. It is during these moments that creativity quietly blossoms. With fewer boundaries between ideas, new associations can form effortlessly. Thoughts that seemed unrelated during the day may gently connect, forming soft insights or imaginative fragments that later fuel creativity and problem solving. This is why rest feels healing. It is not just physical recovery. It is your brain stepping into a quieter internal landscape where thought becomes lighter, softer, and more fluid. As you breathe deeply now, feel that quiet. Feel the soft settling of mental noise as your brain drifts into peaceful openness. Dreams arise from a delicate interplay of memory, emotion, and imagination. They are not random or meaningless. They are the brain's way of gently processing emotional experiences, rebalancing feelings, and weaving fragments of memory into symbolic forms. During REM sleep, your eyes move beneath your eyelids, but your body remains still. The brain becomes active, almost as active as when you are awake, yet it focuses inward. Images appear, dissolve, shift, and blend without effort. Emotional centers, such as the amygdala, glow softly with activity, and so while logical regions temporarily quiet down. This combination allows dreams to take on surreal qualities, familiar yet strange, vivid yet fluid. Dreams are the brain's gentle nighttime therapy, guiding emotional clarity with soft, symbolic storytelling. As dreams unfold, they serve a profound purpose. They help regulate emotional memory, allowing stressful experiences to lose some of their intensity. They help integrate new information, placing it alongside older memories in calm, cohesive networks. Dreams allow the brain to explore possibilities, rehearse future scenarios, and release tension accumulated through the day. Even if you do not remember your dreams, their effects remain, like waves smoothing the surface of sand at night. They gently unwind the mind, loosen emotional knots, and prepare your thoughts for a fresh beginning. As you drift deeper into your own dreaming tonight, know that your brain is quietly working to support your balance, your calm, and your inner harmony. The brain's relationship with time is one of its most subtle mysteries. Unlike the steady ticking of a mechanical clock, your inner sense of time is flexible, shifting quietly depending on attention, emotion, and mental state. When you are deeply engaged in something meaningful, time seems to drift quickly, slipping past like a gentle stream. When you are anxious or waiting, each moment feels long, stretching into slow, heavy intervals. This internal clock is shaped by patterns of neural firing, by the rhythm of dopamine, and by the soft interplay of sensory inputs. The brain does not measure time, it experiences it. Your awareness of time is a feeling, a quiet unfolding shaped by memory and perception. As you rest now, you may feel time slowing, stretching into wide, peaceful spaces that support deeper calm. Bölümanber, paragraph a key. During meditation, daydreaming, or the edge of sleep, the brain's sense of time becomes even more fluid. The prefrontal cortex, the region that keeps track of goals, schedules, and structure, softly reduces its activity. This gentle dimming allows your awareness to loosen. Moments blend, thoughts drift. The boundary between present, past, and imagination becomes thin, almost transparent. This timeless state is deeply restorative because it frees the mind from constant measurement and evaluation. Without the pressure of time, consciousness unfolds like a calm horizon. This is why resting states feel healing. They allow the brain to temporarily release its sense of urgency. As you breathe slowly now, imagine time opening like a quiet doorway, letting your mind drift freely into deeper rest. Bölümaniki, paragraph bar deep within the brainstem, lies a small but essential cluster of neurons, known as the suprachiasmatic nucleus, the master clock of the body. This tiny structure gently synchronizes your circadian rhythm, keeping track of day and night, activity and rest. It responds to light entering the eyes, adjusting hormones, temperature, and alertness based on the time of day. When evening comes and light fades, this internal clock signals the pineal gland to release melatonin, a hormone that softly encourages drowsiness. Your body temperature drops slightly. Your muscles loosen. Your thoughts become slower, softer. This gradual transition prepares you for sleep, guiding you gently toward the deep, restful states your brain depends on. The circadian rhythm influences more than just sleep. It shapes digestion, metabolism, mood, and even the timing of cognitive performance. When this rhythm is aligned, when sleep occurs consistently and naturally, your brain functions with clarity and ease. But when it is disrupted by stress, irregular schedules, or bright light at night, the brain struggles to maintain balance. Melatonin release becomes inconsistent, cortisol rises at the wrong times, and sleep becomes shallow or fragmented. Restoring this rhythm is one of the most gentle and effective ways to support brain health. Small habits, dim lights in the evening, calm routines, steady wake times can help harmonize your internal clock. Tonight, as you unwind, imagine your circadian rhythm settling into a smooth, natural flow, guiding your body toward deep, uninterrupted rest. Inside the brain, emotions are not simply reactions. They are gentle, complex patterns woven through ancient neural circuits. At the center of these emotional pathways lies the amygdala, a small almond-shaped structure that quietly monitors the world for significance. It detects subtle shifts in sound, tone, expression, and memory. Even in sleep, the amygdala remains softly active, guiding the emotional content of dreams and helping the mind gently process stress. Nearby, the hippocampus collaborates with the amygdala, storing emotional memories and weaving them into long-term networks. These two structures work together like partners, one sensing, one remembering, helping you navigate the deep landscape of feeling. As you rest now, imagine these emotional circuits gently calming, their activity slowing, settling into a tranquil rhythm that supports peace and clarity. The prefrontal cortex, resting at the front of your brain, also plays a quiet role in emotional balance. During the day, it gently regulates your reactions, helping you interpret situations logically, guiding responses with thoughtfulness instead of instinct. But at night, as you drift into sleep, the prefrontal cortex relaxes, letting go of its constant control. This soft release allows emotions to surface in dreams, giving the brain space to explore unresolved feelings. This exploration is gentle, imaginative, symbolic, never literal. It is the mind's way of integrating emotional experiences without overwhelming you. When you wake, your emotional landscape often feels clearer, lighter, more organized. This is your brain's quiet healing at work, unfolding softly through the night. Stress, especially chronic stress, can shape the brain in subtle ways. When the body senses threat, the hypothalamus signals the release of cortisol, a hormone that keeps you alert and ready. In small amounts, cortisol is helpful. But when life becomes overwhelming, cortisol remains elevated, gently wearing down neural pathways and making emotional regulation more difficult. Sleep becomes shallow. Thoughts feel rapid, and the mind struggles to unwind. Yet the brain holds a remarkable ability to soften these effects. With consistent rest, calm breathing, and gentle routines, cortisol levels slowly fall. Even a few nights of deep sleep can help the brain restore balance, rebuild emotional resilience, and quiet the systems responsible for stress. During deep sleep, the amygdala becomes less reactive. The prefrontal cortex recovers its strength, and the hippocampus begins reorganizing emotional memories with subtle clarity. This is why sleep often brings relief after difficult days. The brain uses the night to recalibrate, allowing emotional tension to drift out of focus. As you continue listening, imagine the stress circuits in your own mind gently dimming. Picture the amygdala resting, the prefrontal cortex regaining calm stability, and the entire emotional network settling into a soft, synchronized rhythm. With each breath, your inner world becomes quieter, lighter, and more open to deep, restorative sleep. Deep within your brain lies a structure known as the thalamus, an elegant relay station that gently filters sensory information. During the day, the thalamus remains active, guiding sound, touch, taste, and light toward the appropriate regions of the cortex. It sorts, organizes, and redirects these impressions with quiet precision. But as you drift toward sleep, the thalamus gradually closes its sensory gateways. External sounds feel softer, details blur, and the world outside begins to dissolve. This gentle closing is what allows your mind to shift from outward attention to inward rest. As your senses dim, the thalamus prepares your brain for the deeper layers of sleep, allowing your awareness to settle into a quiet, protected inner space. The thalamus also plays a crucial role in generating the rhythmic waves that characterize sleep. Its neurons fire in synchronized patterns, creating oscillations that cascade slowly across the cortex. These waves act like a soft blanket over the brain, calming neural activity and helping the mind unwind from the day's experiences. In this state, the thalamus supports both memory consolidation and emotional regulation, guiding the brain into a place where healing can occur. Tonight, as you continue to drift, imagine your thalamus gently dimming the lights of the outer world, forming a protective boundary that allows your inner world to rest deeply and without interruption. Far beneath the cortex lies the cerebellum, a structure traditionally associated with balance and movement. Yet recent research reveals that the cerebellum quietly influences far more than physical coordination. It helps shape emotional stability, cognitive rhythm, and the smooth flow of thought. Like a soft metronome, it keeps the timing of neural signals steady, ensuring that the brain's networks communicate clearly. When you learn a new skill, playing an instrument, practicing a physical movement, or repeating a calming habit, the cerebellum gently refines the process. It creates pathways of precision, allowing actions and thoughts to flow with graceful ease. During sleep, especially during lighter NREM stages, the cerebellum remains quietly active. It reviews patterns from the day, movements practiced, words spoken, routines repeated. These patterns are refined, smoothed, and stored with subtle accuracy. This is why practice becomes easier after rest, why new skills feel more natural in the morning, and why learning benefits so deeply from sleep. The cerebellum does not shout or dominate. It whispers, it polishes, it gently shapes the rhythm of your mind and body. As you continue listening, imagine your cerebellum as a calm sculptor, refining your abilities softly, patiently, and with a deep sense of harmony. Hidden beneath the surface of conscious awareness lies a vast network known as the limbic system, your emotional core. This interconnected group of structures gently shapes your feelings, motivations, and deep-seated memories. It is ancient, older than language, older than reason, guiding the quiet intuitions that drift through your mind. The limbic system does not speak in words. It speaks in sensations, in subtle shifts of warmth, pressure, tension, and relief. When something feels comforting, or when you sense danger without knowing why, this ancient network is softly at work. As you rest now, imagine the limbic system settling, calming, releasing the emotional echoes of the day. Its gentle hum grows quieter, allowing your inner world to drift into peaceful equilibrium. Within the limbic system, the hippocampus serves as the keeper of memory. Throughout the day, it collects experiences like delicate threads, moments of joy, fragments of conversation, flashes of inspiration. But it is during sleep that these threads are slowly woven into the tapestry of long-term memory. The hippocampus replays patterns from the day in soft bursts of activity, sending them across the cortex where they settle into stable networks. This process gives shape to knowledge, identity, and meaning. It is why certain memories last a lifetime, while others fade gently into the background. As your mind drifts, imagine the hippocampus as a quiet librarian, organizing the shelves of your memory with patient care, placing each moment exactly where it belongs. Just above the brainstem lies a structure called the reticular formation, a delicate web of neurons responsible for maintaining wakefulness and regulating your transitions between sleep and consciousness. During the day, the reticular formation keeps you alert, filtering sensory information and guiding your attention. But as night arrives and your body unwinds, it slowly reduces its activity, allowing the calming chemicals of sleep to rise. This gentle dimming is what creates the sensation of drifting, of slipping from wakefulness into softer states. When the reticular formation quiets, the mind loosens its grip on external reality and turns inward, stepping into a tranquil inner world where thought becomes lighter and more fluid. As you enter deeper sleep, the reticular formation continues its subtle work. It coordinates the transitions between NREM and REM sleep, ensuring that the cycles unfold in smooth, predictable waves. These cycles are essential. NREM restores the body, while REM restores the mind. Without the reticular formation's gentle regulation, sleep would be fragmented, shallow, and unrestful. Instead, its subtle guidance allows each stage to blend seamlessly into the next. Tonight, as your breath slows and your body softens, imagine this network acting as a quiet guardian, guiding you deeper, supporting your rest, and helping your mind drift through the soft layers of sleep. Deep within the brain, near its very center, lies the thalamocortical loop, a quiet circuit that shapes the rhythm of consciousness itself. This loop sends gentle waves of activity back and forth between the thalamus and the cortex, forming the foundation for awareness, perception, and thought. During wakefulness, the loop pulses quickly, like a soft hum that supports focused attention. But as you drift into sleep, these pulses slow, lengthen, and deepen. The loop transforms, shifting from rapid patterns into long, sweeping oscillations that wash across the cortex. These slow rhythms signal to the body and mind that it is time to retreat inward, to let go of the day's pace, and to settle into tranquil rest. As you breathe softly now, imagine those thalamocortical waves rolling through you, steady, calm, and soothing, The thalamocortical loop also plays a vital role in dreaming. During REM sleep, it begins to fire in unique, emotionally rich patterns that weave the fabric of dream imagery. The cortex interprets these signals creatively, forming landscapes, stories, and sensations that feel immersive and alive. Meanwhile, the thalamus gently filters out external input, allowing the mind to explore its inner world without interruption. This combination creates dreams that can feel vivid yet safe, intense yet deeply soothing. Even when dreams carry emotion, they help the brain process feelings in a calm, therapeutic way. Tonight, as your mind prepares to dream, the thalamocortical loop will guide you gently into imagination, protecting your rest while allowing creativity to bloom. At the heart of emotional and cognitive stability lies a chemical balance quietly maintained by the brain's neurotransmitters: serotonin, dopamine, GABA, acetylcholine. Each of these molecules plays a soft, essential role in shaping mood, motivation, relaxation, and clarity. During the day, these chemicals fluctuate in response to experience. But at night, as you begin to unwind, the balance shifts. GABA increases, gently calming neural activity. Serotonin levels support the early stages of rest. Melatonin rises, signaling darkness, safety, and stillness. This cocktail of chemistry guides the brain toward deeper sleep, helping thoughts soften and emotions settle. It is a biological lullaby, unfolding molecule by molecule. As sleep deepens, neurotransmitter patterns transform again. During REM sleep, acetylcholine rises, helping create the vivid imagery of dreams, while norepinephrine and serotonin quiet nearly to silence. This shift allows the brain to explore memory, emotion, and imagination without the constraints of waking logic. It is during this stage that creativity blossoms, emotional tension unwinds, and the mind explores symbolic landscapes that help restore balance. These chemical rhythms, arising and settling in gentle waves, shape the night's journey from light rest to deep sleep and back again. As you continue listening, imagine these neurotransmitters flowing with perfect harmony, guiding you deeper, quieter, and more peacefully into the heart of the night. Your brain is not a single, unified system acting in perfect harmony. It is a collection of networks, distinct yet interconnected, each one drifting in and out of activity like constellations glowing quietly in the night sky. Among these networks, one stands out for its role in helping you navigate complex decisions and logical thought: the executive control network. This network involves regions of the prefrontal cortex and parietal lobes, areas responsible for planning, focus, and deliberate action. During the day, the executive control network remains gently active, guiding your attention, organizing your thoughts, and helping you filter distractions. Yet as night approaches and your mind begins to unwind, this network slowly retreats into stillness. The mental chatter fades. The need to plan and analyze dissolves. The brain softens its grip on structure, making room for the calm, expansive landscapes of rest. As the executive control network quiets, another network rises with gentle prominence: the salience network. This network helps you shift between internal thought and external awareness, deciding what deserves attention. During the day, it scans for meaningful cues: a sudden sound, a familiar face, a memory rising from within. But at night, when sensory input fades and the world becomes still, the salience network drifts into a tranquil, introspective mode. It no longer searches outward. Instead, it allows your awareness to float softly within, supporting the transition into sleep. The balance between these two networks, one stepping back, the other shifting inward, creates the mental spaciousness you feel as you let go of the day. It is a neural choreography, slow and subtle, guiding you deeper into the quiet. Another profound mystery of the brain lies in the way it blends memory, imagination, and creativity. When you recall something from your past, the memory is not retrieved like a file. It is reconstructed. Neurons across different brain regions fire in gentle synchrony, recreating the moment piece by piece. Sounds, colors, emotions, sensations. And when you imagine something new, the brain uses those very same regions, weaving memory fragments into patterns that have never existed before. Creativity is not a sudden spark. It is a slow rearranging of neural pathways, a quiet mixing of the familiar and the unknown. Even now, as you rest, your brain may be softly combining ideas, drifting through mental landscapes, forming connections that will bloom into insight tomorrow. During REM sleep, this gentle blending becomes even more fluid. The boundaries between memory and imagination dissolve. Emotional regions activate, visual regions glow, and logical regions rest, creating a perfect environment for creativity to flourish. Solutions to problems emerge unexpectedly. New ideas form in the background. Emotional memories soften as they mix with symbolic imagery. This is why you may wake with clarity or inspiration, even if you do not remember your dreams. Your brain has been quietly reorganizing, quietly exploring, quietly healing. As you drift deeper tonight, imagine your mind as a vast, peaceful canvas, one where memories, emotions, and ideas glide together like soft brush strokes, forming patterns that guide your growth and understanding. The brain does not simply receive information, it predicts. Every moment, quietly, subtly, it anticipates what will happen next. This constant forecasting is guided by past experience, stored memories, and soft internal models of the world. When you hear footsteps behind you, your brain predicts their rhythm before each step arrives. When you reach for an object, your brain predicts the weight and shape before you touch it. This gentle, predictive process allows your movements to feel smooth, your senses to feel coordinated, and your experience of reality to feel continuous. Without prediction, the world would seem disjointed. Every sound, every sight, every sensation would feel surprising and unfamiliar. Instead, your brain creates a tranquil sense of flow, smoothing the edges of perception, so life feels coherent and stable during sleep. These predictive models are softly refined. The brain evaluates the day's experiences, compares them to its expectations, and quietly adjusts its internal understanding of the world. This subtle recalibration improves emotional balance, decision-making, and even social awareness. It allows you to wake with a clearer sense of what to expect from your environment and how to respond gently and effectively. This process also explains why sleep helps reduce fear and uncertainty. The brain practices, rehearses, and rewrites predictions without conscious effort. Tonight, as you float deeper into rest, imagine your mind gently smoothing its expectations, aligning them with calm clarity, preparing you for tomorrow with quiet wisdom. One of the most fascinating aspects of the brain is its ability to hide information from consciousness. Beneath your awareness lies a deep reservoir of intuition, a quiet intelligence that guides decisions long before the conscious mind arrives. Research shows that the brain often detects patterns, senses emotional tones, and makes subtle judgments several seconds before you become consciously aware of them. This gentle pre-processing is not mystical. It is the result of countless neural circuits working in parallel, evaluating, comparing, and settling into conclusions that rise slowly into awareness. Your gut feelings, your instincts, your subtle impressions. They are all echoes of this quiet, hidden computation. During sleep, this unconscious mind becomes even more active. It revisits unresolved thoughts, explores emotional themes, and forms new connections that the conscious mind may not notice. Dream imagery often reflects this process. Symbols, metaphors, and surreal landscapes that hint at deeper understanding. Even if you do not remember your dreams, your unconscious mind carries their effects into the next day, helping guide your actions with subtle clarity. As you continue to drift tonight, imagine this hidden intelligence as a calm river flowing beneath the surface of awareness. It carries insights, emotions, and ideas gently forward, supporting you quietly, continuously, without needing recognition. It is one of your most powerful allies, always present, always working, always guiding you toward balance. The brain's ability to focus is a delicate and dynamic process, shaped by subtle interactions between neural networks. At the heart of this ability lies the dorsal attention network, which gently guides your focus toward external tasks and sensory details. When you concentrate on a conversation, a moving object, or the sound of someone's voice, this network awakens with calm precision. It does not force attention. It simply nudges your awareness toward what matters. Yet, like all systems in the brain, it becomes tired after long periods of use. Distraction increases, clarity fades, and thoughts begin to drift. This is not a flaw. It is a natural signal that the mind needs rest. As you ease into deeper calm now, imagine this network slowly relaxing, releasing the need to focus, and allowing your awareness to soften. In contrast, The ventral attention network monitors unexpected changes in your environment, soft sounds, subtle movements, or emotional cues that might require attention. During sleep, this network becomes quiet, but never fully shuts down. A loud noise can still gently wake you. A shift in light can softly reshape your dream. This quiet vigilance keeps you safe through the night, but once calm returns, the network settles once more, allowing your mind to drift deeper. These two attention systems, one guiding focus, one monitoring the world, work together effortlessly, forming a balanced cycle of alertness and rest. Tonight, as you settle further into sleep, both networks ease into stillness, creating space for profound healing and tranquility. Hidden in the folds of the temporal lobes lies a region essential for understanding the world: the auditory cortex. This part of your brain gently interprets sound, transforming vibrations in the air into meaningful experiences. Voices, melodies, whispers, and calm tones. Even now, as you listen to this narration, your auditory cortex processes the rhythm of each word, the softness of each pause, and the gentle cadence that carries you deeper. During sleep, this region stays lightly active, ready to detect meaningful or surprising sounds. But its processing becomes slower, quieter, more selective. It filters out unimportant noise and allows only certain signals to pass through, protecting your rest with subtle precision. The auditory cortex also plays a role in shaping memory. Sounds tied to meaningful experiences are processed more deeply, creating emotional impressions that linger long after the moment passes. Music, in particular, leaves traces throughout the brain, forming pathways that awaken emotion, nostalgia, and calm. When you sleep, these pathways hopefully reorganize, strengthening associations that matter and allowing others to fade. This may be why certain sounds feel comforting or familiar even years later. As you unwind, imagine the auditory regions of your brain dimming their activity, resting gently, and preparing to guide you through a night of soothing quietness. Your mind becomes more still, your thoughts soften, and the world around you settles into gentle silence. Deep within the folds of the temporal lobe lies another remarkable region, the fusiform gyrus. This area plays a quiet yet essential role in recognizing faces, shapes, and patterns. It allows you to identify loved ones in an instant, to sense familiarity in a glance, to distinguish subtle expressions that convey emotion. The brain does this gently, almost effortlessly, weaving together visual details into a coherent sense of identity. Even now, your fusiform gyrus stores countless impressions. Faces you have seen briefly, faces you have known for years, and expressions that shaped your emotional memories. During rest, This region calmly reorganizes visual information, refining your ability to read the world with clarity and care. During sleep, the fusiform gyrus participates in a soft recalibration of visual memory. Dream imagery often blends familiar faces with unfamiliar ones, creating fluid combinations that reflect the brain's ongoing process of integration. These surreal blends are not random. They reveal how the mind quietly links emotional meaning to vision, how it stabilizes identity, and how it prepares you to recognize subtle cues in others. As you drift deeper tonight, imagine this part of your brain gently dimming, resting from the constant task of interpreting faces and expressions. Allow the visual world to become soft and distant as your awareness sinks into inner calm. Far beneath conscious awareness, your brain continuously tracks the position of your body in space. This sense, known as proprioception, arises from networks that integrate signals from muscles, joints, and the inner ear. It allows you to walk without watching your feet, to reach for objects without measuring every angle, to move through the whirl with fluid ease. The parietal cortex, cerebellum, and somatosensory regions work together in quiet harmony, blending sensory input into a stable sense of self-location. Even when your eyes are closed, the brain holds a soft, internal map of your body, its shape, its posture, its presence. As you settle into rest now, that internal map begins to quiet, drifting into a gentle stillness that supports deep relaxation. During sleep, proprioceptive systems shift into a tranquil mode. Muscles relax, reflexes calm, and the body becomes almost weightless in the mind's representation. This shift allows the brain to conserve energy, redirecting resources toward healing, restoration, and memory consolidation. It is also why dreams often involve floating, gliding, or moving effortlessly through space. The brain explores motion in a world free from physical limits. As you breathe slowly now, imagine your body sinking deeper into comfort, its boundaries becoming softer, its weight dissolving into the mattress. Your proprioceptive map fades gently, allowing your mind to drift into peaceful openness. Nestled deep within the brain is the insular cortex, a region that quietly monitors your internal world. It senses subtle shifts in heartbeat, breath, temperature, and emotion. This awareness, called interoception, helps create the feeling of being grounded in your own body. The insula blends physical signals with emotional tones, allowing you to recognize comfort, tension, calm, or unease without needing words. Even now, as you breathe gently, the insula tracks the soft expansion of your lungs and the slow rhythm of your heartbeat. It works silently, giving shape to intuition and helping your mind understand what your body needs. As the night deepens, this region gradually softens its activity, guiding you into a quieter relationship with your inner sensations. During sleep, the insula reduces its sensitivity, allowing the body to rest without constant internal monitoring. This decrease in awareness supports deeper relaxation, freeing your attention from physical sensations and allowing your mind to drift into spacious, quiet states. Yet the insula does not disappear. It remains gently watchful, alert enough to notice discomfort or danger, but calm enough to support uninterrupted sleep. This delicate balance helps maintain safety through the night while preserving the restorative rhythm your brain depends on. As you settle further into rest, imagine your insula dimming like a lantern at dusk, still glowing softly, but no longer guiding the mind with constant signals. In its place comes stillness, openness, and deep inner quiet. Emotions often feel like storms, sudden, overwhelming, unpredictable. But within the brain, they are patterns of activity shaped by chemistry, memory, and the gentle choreography of neural circuits. The prefrontal cortex, amygdala, hippocampus, and insula work together in layers, each adding a different dimension to emotional experience. During waking hours, these circuits respond to the world, softening joy, amplifying fear, coloring memories with warmth or tension. But as night comes, emotional circuits begin to loosen. Neurotransmitters shift, stress pathways lower, and the brain gently distances itself from the emotional intensity of the day. This is why nighttime often brings relief, why feelings soften and thoughts slow, giving the mind space to breathe. During REM sleep, emotional regions become active again, but in a different, more fluid way. The brain revisits emotional memories without the full force of waking awareness. Fear becomes symbolic, sadness becomes story-like, and joy becomes imagery drifting softly through the dream. The prefrontal cortex remains quiet during this stage, which allows emotional material to move freely through the mind. This process is crucial for mental health. It helps the brain process unresolved feelings, reduce stress, and restore emotional balance. As you continue your slow drift into deeper rhythms, imagine your emotional circuits unwinding, gently releasing, gently settling, gently healing. At the foundation of every thought, every memory, and every emotion lies the quiet flow of electrical activity through neurons. This activity is governed by ion channels, tiny gateways that open and close in response to soft changes in voltage. Sodium, potassium, calcium, and chloride drift across these channels in balanced rhythms, creating the signals that shape your entire experience of being alive. These microscopic movements occur silently, billions of times each second, yet you never feel them. They are the gentle heartbeat of your neural world. As your body relaxes and your breath deepens, this electrical activity begins to synchronize into slower, more harmonious patterns. The busyness of the day dissolves, and the brain prepares for deeper, more restorative states of calm. During sleep, these electrical rhythms become even more organized. Neurons fire in waves, smooth, repeating patterns that wash across the cortex like tides across sand. These slow oscillations help consolidate memories, clear waste, and reset networks for the next day. Delta waves rise during deep sleep, creating intervals of profound stillness. Sleep spindles, brief bursts of activity, support learning and sensory protection. Each pattern has purpose. Each wave brings renewal. As you drift deeper into rest, these rhythms will guide you, carrying your awareness into tranquil states where healing unfolds naturally. Your brain, with its quiet electrical ballet, becomes a landscape of soft pulses and gentle silence. One of the brain's most mysterious qualities is consciousness, the quiet awareness that lets you experience the world, reflect on yourself, and sense the passing of time. Scientists still do not fully understand how consciousness emerges from neural activity, but we know it relies on the synchronized communication of distant brain regions. Networks such as the default mode, salience, and executive control systems interact in subtle ways, creating the fluid experience of being you. During the day, consciousness feels continuous and stable. But at night, as sleep deepens, these networks gently uncouple. Awareness fades not suddenly, but softly, like a light dimming rather than switching off. As you enter deeper stages of sleep, the boundaries between waking consciousness and unconscious processing dissolve. The brain continues working, refining memories, exploring emotions, regulating the body, but without the narrative stream of self-awareness. This state is not emptiness. It is restoration. It is the mind returning to stillness, recalibrating the networks that shape identity and perception. When you awaken, consciousness reassembles itself with quiet elegance, reconnecting the pieces into a coherent whole. As you drift further tonight, imagine your awareness softening, loosening, and gently expanding into peaceful non-resistance. Let go of the need to think. Let go of the need to observe. Allow your mind to sink effortlessly into the quiet mystery beneath thought. Within your brain, the sense of touch is processed through a gentle network known as the somatosensory cortex. This region interprets signals from your skin, muscles, and joints. Soft pressure, warmth, coolness, and comfort. Throughout the day, it helps you navigate the world with precision, responding instantly to every texture and temperature you encounter. But at night, as your body settles and your muscles release tension, the somatosensory cortex slowly quiets. Signals grow faint. Sensations become muted. the mind stops tracking every shift in posture or every brush of fabric. This gradual dimming allows the body to feel heavier, calmer, and more grounded. It is a soft descent into physical stillness, preparing you for deep rest. During deeper stages of sleep, somatosensory activity becomes minimal, creating a profound sense of bodily peace. This reduction in sensory input allows the brain to redirect energy toward repair and regeneration. Muscles recover, tissue heals, and inflammation is reduced. The quieting of touch also contributes to the floating sensation many people feel as they drift into sleep, the body becoming lighter, almost distant, as the mind transitions inward. As you drift further now, imagine your physical senses softening like waves settling after a long day. Each breath slows the system. Each moment carries you deeper into peaceful, restorative quiet. Smell is one of the oldest senses in the brain, ancient, primal, and deeply tied to memory and emotion. The olfactory bulb, located just above the nasal cavity, connects directly to the limbic system, bypassing the thalamus entirely. This unique pathway explains why scents can evoke vivid memories or emotions instantly. A familiar fragrance can transport you to another time with remarkable clarity. During the day, your olfactory system constantly samples the air, detecting subtle chemical signatures around you. But at night, especially during deeper sleep, the system grows quiet. Despite this quieting, the olfactory system continues gentle background activity as the brain processes scent-related memories. This may influence the emotional tone of dreams, blending past experiences into soft imaginary landscapes. Smells tied to comfort, fresh air, warm blankets, familiar spaces often help signal safety, supporting relaxation as you fall asleep. As you rest now, imagine the olfactory pathways in your brain dimming like soft candlelight. They fade into calmness, leaving only the faintest traces of memory and comfort. This gentle dimming deepens your sense of safety, guiding your mind further into peaceful, uninterrupted sleep. Taste, though subtle and often overlooked, is carried by a delicate network that connects the tongue, brainstem, and the gustatory cortex deep within the insular region. Throughout the day, the system gently decodes flavors: sweetness that calms, saltiness that awakens, bitterness that warns, and warmth that comforts. Each flavor carries emotional weight, shaped by memory and culture. A familiar meal can bring peace, while an unexpected taste can evoke ancient survival instincts. But as night falls, the gustatory system retreats into quiet. The tongue still senses, but the brain no longer prioritizes these signals. This shift helps the body conserve energy, allowing its focus to turn inward toward healing, restoration, and calm. It is a gentle reminder that the senses, too, rest with you. During deeper stages of sleep, the brain significantly reduces its responsiveness to taste. Eating is impossible during sleep, and so the gustatory system enters a dormant phase, drifting into stillness. Yet the brain may still weave flavor into dreams. Sweet fruit, warm tea, the comfort of familiar foods. These dream sensations arise not from the tongue, but from the memory pathways intertwined with emotion. The brain replays these impressions as symbols of safety, nourishment, and warmth. As your mind softens now, imagine the taste centers within your cortex gently dimming, becoming silent pools of memory and sensation. Let this quiet contribute to a deeper sense of tranquility as the night unfolds. Far deeper within the brain lies a system of extraordinary importance: the reward pathways. These circuits, woven through the ventral striatum and the prefrontal cortex, help shape motivation, learning, and the gentle sense of satisfaction that accompanies meaningful experiences. Dopamine, often misunderstood, does not create pleasure. It creates anticipation, the soft pull towards something rewarding. Throughout the day, dopamine guides decisions, encourages exploration, and marks moments that matter. But at night, the reward system grows quiet. Dopamine release slows, cravings dissolve, and the brain turns away from outward pursuit toward inner balance. This shift supports restful sleep, reducing mental restlessness and bringing calm. During REM sleep, reward circuits activate again, but in a different, dreamlike way. They replay emotional experiences, helping the brain refine motivation, reshape habits, and soften the edges of stress. Dreams involving movement, connection, or success often reflect this gentle recalibration of the reward system. It is not about desire, it is about healing. As dopamine settles into balanced rhythms, the brain awakens the next morning with renewed clarity and motivation. Tonight, as your awareness drifts deeper, imagine your reward system settling into perfect equilibrium. Allow all desires, pressures, and expectations to loosen. Let the mind drift free of urgency, guided only by the quiet embrace of rest. Deep within the structure of the brain lies the remarkable ability to use language, an intricate collaboration between Broca's area, Wernicke's area, and the surrounding cortical regions. These areas gently shape all words, meaning, tone, and comprehension. During the day, they coordinate effortlessly, helping you speak, listen, read, and understand the world around you. Language feels immediate, but behind each sentence lies a complex sequence of neural activity unfolding in milliseconds. As night comes and your mind begins to soften, these language centers slowly step back. Words become less sharp, inner dialogue fades, and the steady stream of thoughts becomes quieter. This gentle reduction in verbal processing allows the brain to slip more easily into subconscious states, where silence carries more power than language. During deeper stages of sleep, the parts of the brain responsible for speech and comprehension enter a tranquil phase. They are not inactive, they simply drift into a receptive state, where the focus turns from creating language to integrating it. During dreams, these regions can activate in soft, symbolic ways, producing narratives that blend words, images, and emotion. The brain may whisper fragments of conversation or form dream dialogues that feel familiar yet illogical. These dream sentences often carry emotional meaning more than literal sense. As you drift deeper now, imagine your language centers dimming gently, releasing the need to think in words, allowing your mind to rest in pure sensation, imagery, and calm. Hidden in the underside of the brain lies a small but powerful structure, the basal ganglia. This network of nuclei helps shape habits, routines, and the smooth execution of movements. Throughout the day, it gently reinforces behaviors you repeat, embedding them into procedural memory. Whether you tie your shoes, brush your teeth, or follow a familiar route home, the basal ganglia supports these actions with quiet efficiency. It allows behavior to feel automatic, effortless, and fluid. But at night, as your consciousness withdraws, the basal ganglia shift into a restorative state. Neural pathways associated with repetitive actions are reviewed, strengthened, or softened based on the day's experiences. During sleep, especially during NREM cycles, the basal ganglia engages in subtle recalibration. Habits tied to stress or tension begin to lose their grip, while habits connected to calmness become more stable. This nightly refinement helps free the mind from unhelpful routines and reinforces healthier patterns. It is the brain's way of gently resetting your behavioral compass. When you wake, actions that once felt difficult may feel easier, and old habits may feel less compelling. As you settle further into this soothing journey, imagine your basal ganglia smoothing the edges of your routines, softly encouraging balance, ease, and well-being. Inside the brain, one of the most subtle systems shaping your internal world is the network responsible for decision-making. This delicate process involves the prefrontal cortex, the orbitofrontal cortex, and the anterior cingulate cortex, regions that quietly evaluate possibilities, weigh risks, and imagine outcomes. Throughout the day, these areas work like thoughtful advisors, helping you choose actions that align with your values and needs. But decision-making is rarely logical alone. It is woven with emotion, memory, and intuition. As night falls, These networks slowly loosen their grip. The pressure to choose, to evaluate, to analyze, gently fades. This soft release is essential, giving the mind permission to rest without the constant hum of mental judgment. During deep sleep, decision-making networks enter a restorative quiet. They are still active, but their activity shifts from evaluating choices to reorganizing information. The brain replays fragments of the day, assessing them in a calmer environment. Emotional weight is softened, unnecessary details are removed, and the mind refines its understanding of what truly matters. This nightly recalibration helps you wake clearer, more decisive, and more aligned with your intentions. Dreams often reflect this process, symbolic scenarios where the mind explores choices without consequence. As you ease deeper into rest, imagine your decision-making systems settling into stillness, preparing you for a tomorrow, guided by clarity and calm confidence. One of the brain's most profound talents is its ability to simulate the future. This quiet projection happens in networks involving the hippocampus, prefrontal cortex, and regions responsible for imagination. When you plan your day, rehearse a conversation, or picture a goal, the brain is gently modeling possibilities, testing outcomes without needing to act them out. This ability to mentally travel through time is deeply connected to memory. The same neural pathways used to recall the past help you imagine what has not yet happened. During wakefulness, this simulation can be a source of motivation, creativity, or, at times, worry. Yet at night, as sleep deepens, the need to simulate fades, allowing the mind to retreat from the future and rest fully in the present moment. During REM sleep, future thinking transforms into something more fluid. The brain rehearses possibilities in symbolic, dreamlike forms, practicing emotional responses, refining expectations, and preparing for challenges without the pressure of reality. These dream rehearsals strengthen emotional resilience and help regulate stress. They allow you to wake feeling more ready for the unknown, more steady in the face of uncertainty. As your breath softens now, imagine the future-oriented circuits of your mind dimming into stillness. Let the pressure of tomorrow dissolve. Allow your awareness to drift into a quiet space where there is no past to recall and no future to predict. Only calm, gentle presence. At the base of the brain lies the brainstem, one of the most ancient structures in your nervous system. It quietly regulates heartbeat, breathing, and the essential rhythms that sustain life. Unlike higher regions of the brainstem does not think or plan. It simply maintains, protects, and preserves. Throughout the day, it responds to stress with subtle changes in breath or heart rate. At night, when the body settles into stillness, the brainstem guides your physiology into a state of calm equilibrium. Breaths become deeper and slower. The heart settles into a gentle, steady rhythm. Muscles loosen. The entire system shifts into a mode of restoration. This effortless transition is one of the reasons sleep feels so deeply soothing. It aligns your inner rhythms with peace. During deep sleep, the brainstem continues its careful orchestration. It regulates muscle tone, coordinates the cycles of REM and NREM sleep, and ensures that breathing remains smooth even as consciousness fades. The brainstem also communicates with the spinal cord, calming reflexes and protecting the body through the night. It is the silent guardian of your sleep, working tirelessly without ever asking for recognition. As you drift further into rest, imagine your brainstem stabilizing every rhythm within you, your breath moving like slow waves, your heart beating with steady softness. Feel your entire body surrender to its guidance, trusting the ancient wisdom that keeps you safe through the night. Deep in the center of the brain lies the corpus callosum, a wide band of neural fibers that acts as a bridge between the left and right hemispheres. During the day, this bridge allows the two sides of the brain to share information, logic blending with creativity, language intertwining with emotion, detail balancing with the big picture. It is this connection that gives you fluid intelligence and unified consciousness. But at night, the communication across the corpus callosum becomes softer, more rhythmic. The hemispheres begin to drift into their own gentle patterns of activity, creating a peaceful separation that supports deeper sleep. Interestingly, during REM sleep, communication across the corpus callosum increases again, allowing the hemispheres to weave together imagery, memory, and emotion. This synchronization contributes to the vividness of dreams, the left hemisphere adding structure, the right hemisphere adding imagery, both working together to create internal landscapes that feel immersive and alive. This gentle interplay helps the brain integrate emotional experiences and refine creative thought. As you drift deeper, imagine the two halves of your brain communicating like quiet companions, sharing whispers of memory, soft images, and emotional threads that settle into harmony. Let this internal unity bring you deeper into calmness as the night unfolds. Deep within the brain lies the vestibular system, a gentle network responsible for your sense of balance and spatial orientation. It works through delicate structures in the inner ear, tiny fluid-filled canals that respond to movement, tilt, and gravity. Throughout the day, this system helps you walk, turn, and move with effortless coordination. But at night, when your body finally becomes still, the vestibular system softens its activity. With no need to adjust or stabilize your posture, its signals become faint and quiet. This gentle reduction contributes to the sensation of sinking, floating, or drifting that often accompanies the beginning of sleep. As you relax, imagine this system letting go, releasing its hold on your position in space, allowing your awareness to feel free and unanchored. During dreams, the vestibular system sometimes reawakens in subtle ways, creating sensations of motion, gliding through the air, falling softly, or moving weightlessly through imagined landscapes. These dream movements are not literal. They are symbolic reflections of emotional transitions, inner shifts, and the brain's exploration of spatial memory. The floating feeling rises from the brain blending vestibular signals with creativity and imagination. As you drift deeper tonight, allow this sense of weightlessness to guide you. Feel your body gently dissolving into the mattress, your internal sense of space becoming softer, wider, and more open. Let the vestibular system rest, supporting your descent into profound, peaceful sleep. Another remarkable feature of the brain is its ability to regulate temperature with astonishing precision. Deep in the hypothalamus lies a cluster of neurons responsible for sensing even the slightest fluctuations in body heat. Throughout the day, these cells adjust sweating, shivering, and blood flow to maintain balance. But as night falls, the brain gently lowers your core temperature to prepare for sleep. This subtle cooling signals the body that it is safe to rest, calming metabolism and slowing internal rhythms. The drop is small, yet it has a profound effect. It invites the nervous system to unwind, relax, and drift into deeper stages of sleep. As you breathe slowly now, imagine your internal temperature settling into perfect equilibrium, like cool air drifting across a calm lake at dusk. During deep sleep, temperature regulation becomes even more refined. Blood vessels in the skin relax, allowing heat to dissipate. Muscles loosen, reducing internal heat production. This gentle cooling supports the brain's restorative processes, helping clear waste, consolidate memory, and stabilize emotional networks. If the temperature rises too much, the brain stirs lightly, adjusting position or prompting a brief awakening to restore balance. This quiet dance ensures that sleep remains healing and protective. Tonight, feel your body releasing warmth with each exhale, growing cooler, softer, and more at ease. Let this natural temperature shift guide you into deeper tranquility, where your brain and body find perfect harmony. Deep within the layers of the brain lies the prefrontal cortex, a region responsible for self-awareness, reflection, and the gentle shaping of your identity. During the day, it orchestrates decisions, weighs possibilities, and helps define the quiet narrative you call yourself. It guides your moral judgments, your values, and the subtle sense of who you are in relation to the world. But at night, as your body settles and your thoughts loosen, the prefrontal cortex slowly steps back. Self-awareness softens. The boundaries of identity become lighter, less defined. This gentle fading of the self allows the mind to drift away from responsibility, pressure, and expectation. It is a sacred release, an invitation to rest without the weight of being you. During deeper stages of sleep, the prefrontal cortex becomes one of the least active regions in the brain. This quieting allows emotions to move freely, dreams to unfold without logic, and the mind to explore symbolic landscapes unbound by self-control. The temporary fading of identity is healing. It provides relief from the constant inner dialogue that accompanies waking life. When you awaken, the prefrontal cortex gently reassembles your sense of self, clearer and more balanced than before. As you drift deeper now, imagine your self-awareness yielding to softness, dissolving into stillness. Allow your mind to rest without analysis, without reflection, without the need to hold onto any version of yourself. Deep in the temporal lobes lies an extraordinary structure known as the hippocampus, responsible for forming new memories and weaving them into long-term storage. Throughout the day, it silently records experiences, moments of meaning, fragments of conversation, feelings that linger just beneath the surface. But the hippocampus does not work alone. It collaborates with the cortex and limbic system to turn fleeting impressions into lasting memories. As night falls, this structure prepares for its most important task. It slows, reorganizes, and gently begins replaying the patterns of the day, sending them outward to the cortex for storage. During NREM sleep, the hippocampus becomes a quiet storyteller, replaying compressed versions of waking experiences in slow, rhythmic bursts. These bursts guide cortical regions in strengthening or releasing connections, forming memories with remarkable efficiency. During REM sleep, emotional memories receive special attention, allowing the brain to process feelings through dream imagery. This gentle interplay ensures that what is meaningful remains and what is unnecessary fades. As you continue to unwind, imagine your hippocampus softly sorting the experiences of your day, organizing, refining, and placing each memory where it belongs. Let your mind rest, knowing that this process unfolds naturally as you drift deeper into calm. Deep within the brain's emotional architecture rests the amygdala, a small almond-shaped structure responsible for detecting significance, especially emotional signals tied to fear, safety, and connection. During waking hours, the amygdala responds quickly, helping you navigate the world with instinctive awareness. It senses tone in a voice, expression on a face, or tension in a moment long before conscious thought arrives. But as night comes, the amygdala's intensity softens. It no longer needs to stand guard with the same vigilance. Its activity becomes slower, gentler, preparing the emotional system for healing rather than defense. This shift allows the mind to release tension and sink into a quieter internal space. During REM sleep, the amygdala becomes active again, but in a safe, symbolic environment. Dreams allow emotional memories to unfold without real-world consequences. Fears appear in softened forms, worries stretch into surreal shapes, and unresolved emotions drift through imagined scenes. This gentle reprocessing reduces the emotional weight carried by the amygdala, helping the mind awaken with greater calm and resilience. As you drift deeper tonight, imagine the amygdala releasing its daytime burdens, loosening its hold, softening its edges, allowing each emotion to float freely through the night, becoming lighter with every breath you take. Resting just behind the forehead lies the orbitofrontal cortex, a region responsible for interpreting reward, evaluating emotional meaning, and shaping subtle social behaviors. It helps you understand whether an experience feels comforting, exciting, or unsettling. It quietly weighs consequences and shapes your preferences, often without your awareness. During the day, it remains active, blending emotion and logic into a cohesive sense of value. But as night unfolds, the orbitofrontal cortex gradually calms. The need to evaluate fades, the drive to interpret emotion softens. This allows the mind to enter a state of emotional neutrality, where experiences can be reorganized without judgment. During sleep, the orbitofrontal cortex contributes to emotional recalibration. It participates in refining the meaning of past experiences, helping disconnect unnecessary emotional intensity from memories. This is why, after sleep, some worries feel smaller and certain feelings become clearer. The brain has gently reassessed them in the safety of dreams. As you relax further into stillness, imagine this region resting quietly, its evaluative voice growing softer, its influence easing, to making space for emotional balance to return naturally. Let the weight of interpretation dissolve. Allow your inner world to float into a calm, restorative quiet. Deep within the brain's intricate emotional system lies the anterior cingulate cortex, a region that gently integrates thought, emotion, and attention. During the day, it helps you navigate conflict, detect subtle changes in mood, and maintain a sense of connection to your goals. It balances your emotional reactions with your rational mind, allowing you to respond instead of merely react. But as night approaches, the anterior cingulate slowly relaxes its constant monitoring. The pressures of the day fade from its circuits. Tension loosens. Its tone becomes softer, lighter, more open to rest. This quieting allows the mind to become less self-critical, less vigilant, more compassionate toward itself. During sleep, the anterior cingulate participates in emotional healing. In the dream state, it collaborates with regions like the hippocampus and amygdala to refine the emotional meaning of experiences. Conflicts soften, fears become symbolic, and unresolved feelings find gentle resolution. This nightly recalibration helps restore emotional resilience, making you better prepared for the challenges of a new day. As you drift deeper, imagine this region settling into calm rhythm, balancing your inner world with tender equilibrium, letting judgment fade and inviting self-kindness to take its place. Hidden within the deepest folds of the cortex lies the insula, a region that quietly maps your internal world. It senses the gentle rhythm of your heartbeat, the softness of your breath, the subtle shifts of your organs. This awareness, known as interoception, shapes your emotional landscape and your sense of presence. During waking life, the insula helps you recognize hunger, calm, tension, and even intuition. But at night, as the body becomes still, the insula gradually withdraws from constant monitoring. Its signals fade into softness, allowing the body to rest without persistent awareness of physical sensation. During sleep, the insula enters a restorative mode. It no longer alerts you to discomfort with the same intensity. Instead, it works quietly in the background, integrating emotional and bodily states with gentle precision. This is one reason why deep sleep can feel like floating, because the insula's sensory map of the body becomes quiet, partial, and spacious. As you drift further into rest, imagine your internal world becoming softer, wider, and more peaceful. Allow the insula to dim its signals, leaving you with a comforting sensation of dissolving gently into the quiet around you. Deep in the brain's quiet architecture lies the posterior cingulate cortex, a region closely tied to self-reflection, memory, and the gentle drifting of the mind when it wanders. During the day, it connects past experiences with present thoughts, helping you understand who you are and how you feel. It anchors your sense of continuity, your quiet inner story. But at night, As drowsiness begins to soften awareness, the posterior cingulate slowly dims. The sense of self becomes less rigid, less defined. Thoughts adrift without direction. Memories loosen their boundaries and flow more freely. This gentle unraveling creates the spacious mental openness that allows sleep to approach without resistance. During deep sleep, the posterior cingulate becomes one of the most subdued regions in the brain. Its quieting allows the mind to release the constant narrative that shapes waking consciousness. Without this story running in the background, the brain can focus entirely on restoration, clearing waste, consolidating memory, and calming emotional circuits. The temporary fading of the self is deeply healing, creating a break from reflection, identity, and internal dialogue. As you settle deeper into rest, imagine this region softening, like a lantern turning low. Let your inner story pause. Let your awareness become light, open, and gently silent. Nestled between the emotions of the limbic system and the logic of the frontal lobes lies the ventromedial prefrontal cortex, a region essential for empathy, compassion, and emotional understanding. Throughout the day, it helps you interpret other people's feelings, adjust your tone, and navigate social moments with subtlety. It bridges emotion with reason, allowing you to make choices that reflect kindness and deeper meaning. But when night arrives, this region shifts into a quieter state. Social concerns fade, interpersonal worries loosen. The soft pressure to interpret and respond to others gradually dissolves, allowing your mind to turn inward and find stillness. During sleep, especially in REM stages, the ventromedial prefrontal cortex activates gently, helping refine emotional understanding. It processes experiences of the day, moments of connection, moments of misunderstanding, and reshapes them in symbolic dream imagery. This nightly emotional recalibration supports your ability to empathize, forgive, and heal. When you awaken, you often feel more balanced, more grounded, more open. As you drift deeper now, imagine this region of your brain glowing softly, performing its tender nighttime work. Let empathy toward yourself rise. Let judgment fall away. Allow emotional clarity to form quietly beneath this surface, preparing you for a new day with a lighter heart. Deep beneath conscious awareness lies the dorsal striatum, a region essential for shaping long-term habits and fluid daily routines. Throughout the day, it quietly transforms repeated actions into automatic behaviors, tying your shoes, locking the door, following familiar paths without needing to think. These habits conserve mental energy, allowing the brain to focus on more complex tasks. But at night, as the body grows still, the dorsal striatum shifts into a soft mode of refinement. Habit circuits loosen, unhelpful patterns weaken, and healthier routines become slightly stronger. This gentle recalibration helps you wake with a subtle shift toward clarity. Less pulled by old habits, more open to intentional action. During deeper cycles of sleep, the dorsal striatum collaborates with the cortex to replay learned behaviors. Skills practiced during the day are refined in slow, rhythmic bursts of activity. This is why repetition feels easier after rest. The brain rehearses not through force, but through quiet, effortless replay. At the same time, habits tied to stress or exhaustion begin to lose their grip, making room for healthier neural patterns. As you drift further into calm now, imagine your habit pathways softening, loosening the automatic patterns that no longer serve you. gently strengthening the ones that support peace and balance. In the center of the brain lies the thalamus, a delicate gateway that regulates the flow of sensory information. During waking hours, it continuously receives sounds, sights, touches, and movements, distributing them to the appropriate regions with remarkable precision. But as sleep begins, the thalamus gradually closes these sensory gates. External noise fades, light becomes less meaningful, and the world outside loses its pull. This shutdown is essential. It protects your internal world from interruption, allowing the mind to shift toward dreams and deeper stages of rest. The quieting of the thalamus marks the true threshold of sleep, guiding you from alertness into gentle inward drifting. During NREM sleep, the thalamus generates rhythmic waves that flow slowly across the cortex. These waves help stabilize sleep, protect it from waking, and support the brain's nighttime healing processes. Sleep spindles, brief bursts of activity, also emerge from the thalamus, assisting with memory consolidation and emotional resetting. During REM sleep, the thalamus reopens slightly, allowing internal sensory experiences to flourish into vivid dreams while still blocking most external input. As you sink deeper now, imagine the thalamus dimming, closing its gates to the outside world, and guiding your mind gently toward the quiet, protected landscape of deep rest. Deep within the brain's internal landscape lies the intricate network responsible for regulating pain, the descending pain modulation system. Throughout the day, this system works in delicate balance, interpreting signals from the body and blending them with emotion, memory, and expectation. Pain is never just physical. It is shaped by the brain's interpretation. But as night approaches, the brain's pain processing circuits begin to soften. The prefrontal cortex, amygdala, and periaqueductal gray shift into calmer rhythms, reducing the emotional intensity tied to discomfort. This quieting allows the body to rest more easily, creating a gentle sense of relief that helps sleep take hold. During deep sleep, the descending pain system becomes even more protective. Endogenous opioids, the brain's natural pain-relieving chemicals, are released in subtle waves, soothing the nervous system. Muscles relax, inflammation decreases, and pain signals lose their sharpness. This is why sleep is one of the most powerful natural healers available to the body. It is not just rest, it is recalibration. As you drift deeper now, imagine any tension or discomfort dissolving like mist. Visualize your brain's pain circuits becoming softer, quieter, and more distant, allowing your entire being to sink into profound physical ease. The brain's relationship with sound changes dramatically as you fall asleep. During wakefulness, the auditory cortex works tirelessly, interpreting every vibration with astonishing speed. A distant voice, a closing door, a shift in tone. Each sound is analyzed for meaning, but as sleep draws near, the brain begins to filter sound differently. Familiar noises fade, gentle sounds soothe, and the auditory system becomes selective, allowing only significant stimuli to reach awareness. This careful filtering protects your rest, preventing unnecessary awakenings while keeping you safe from truly important sounds. During deeper sleep, the auditory cortex becomes even less responsive. Its neural activity settles into rhythmic waves, and most external sounds drift past without recognition. Yet the brain remains subtly aware, ready to wake if something meaningful occurs. Inside dreams, however, the auditory world transforms. The brain creates sounds from memory, voices, music, whispers, echoes of the day. These dream sounds feel vivid, yet they are entirely internal, crafted by imagination. As you drift further into stillness, let your auditory world soften. Allow real sounds to fade into the background, and dream sounds to rise gently when the brain is ready. Let this quiet guide you deeper into peaceful sleep. Deep in the frontal lobes lies the dorsolateral prefrontal cortex, a region essential for working memory, planning, and organizing thought. Throughout the day, it helps you hold ideas in mind, solve problems, and navigate complex decisions. It is one of the most active regions when you concentrate or think strategically. But as night approaches and the mind eases into softer states, this region gracefully releases its grip. Thoughts become less sharp, tasks lose urgency, and mental lists quietly dissolve. This gradual unwinding allows the mind to slide into a more fluid, intuitive state, creating space for dreams and subconscious processing to take over. During sleep, especially deep NREM cycles, the dorsolateral prefrontal cortex becomes one of the most silent areas of the brain. This silence allows other regions, notably emotional and memory networks, to communicate more freely. The absence of logical oversight is one reason dreams feel surreal and unconstrained. Yet this temporary shutdown also brings healing. Freed from constant responsibility, the prefrontal cortex rests, resets, and returns stronger by morning. As you sink deeper into rest now, imagine the thinking part of your mind dimming like a light at dusk, soft, slow, and peaceful. Another quiet guardian of your inner world is the hypothalamus, a small but powerful structure responsible for regulating hunger, thirst, hormones, and your internal clocks. It continuously monitors the body's needs, gently adjusting temperature, metabolism, and emotions to maintain balance. During the day, these adjustments happen seamlessly, helping you stay grounded and stable. But at night, the hypothalamus shifts into a different mode. It guides the release of melatonin, lowers internal temperature, and supports the chemistry of sleep, ensuring that the body transitions into restorative states with grace and ease. During deeper sleep, the hypothalamus continues to oversee essential rhythms, but with a softer touch. Growth hormone is released in steady pulses, supporting tissue repair and cellular renewal. Cortisol levels fall, allowing the nervous system to calm. Appetite-regulating hormones rebalance, preparing the body for a fresh start the next day. The hypothalamus becomes a silent conductor, orchestrating cycles of repair and regulation without ever disturbing your rest. As you breathe slowly now, imagine your internal system sinking gently, guided by this ancient, intuitive center. Let your body feel protected, balanced, and deeply supported as you drift further into sleep. Deep within the brain's emotional and motivational pathways lies the nucleus accumbens, a region that gently shapes anticipation, pleasure, and the calming sense of satisfaction that accompanies meaningful experiences. During the day, this structure responds to positive events, subtle rewards, comforting interactions, and moments of motivation. It helps you feel engaged with life, drawn toward what matters, soothed by what feels good. But as the night unfolds, the nucleus accumbens softens its activity. The pull of desire loosens. The drive to pursue, achieve, or seek reward slowly fades into a quiet hum. This calming shift allows the mind to let go of outward focus and settle into inward stillness. During sleep, the nucleus accumbens works in gentle harmony with the rest of the limbic system, helping rebalance emotional drives. Dreaming adds symbolic imagery to these processes, allowing the brain to rehearse positive feelings, release stress, and reorganize emotional priorities. This quiet recalibration supports a healthier sense of motivation when you awaken, less driven by urgency, more aligned with calm intention. As you continue drifting into deeper rest, imagine the reward pathways dimming, soothing your inner world, and gently resetting your emotional compass for the next day. Nestled just behind the temples lies the temporal cortex, a region deeply involved in processing sound, language, and memory. It helps you recognize voices, understand meaning, and recall experiences rich with emotional detail. Throughout the day, the temporal cortex weaves together what you hear and what you remember, adding depth and context to your perception of the world. But as night draws in, this region begins to relax. The constant flow of auditory information slows, memories loosen their structure, and the mind becomes more receptive to dreamlike associations. During sleep, the temporal cortex plays a quiet but essential role in creating the soundscapes of dreams. Voices may blend, echoes may appear from distant memories, and familiar tones may transform into calming whispers. The cortex draws from emotional memory, weaving sound into the symbolic narratives of the dream state. These internal sounds feel real because they are crafted from the same neural pathways that interpret waking audio. As you drift deeper now, imagine the temporal cortex softening, releasing the noise of the outside world. Allow your inner soundscape to become gentle, distant, and soothing, an invitation to sink further into the quiet ocean of sleep. Deep in the brain's hidden networks lies the precuneus, a region quietly involved in imagination, self-reflection, and the gentle construction of mental imagery. Throughout the day, it helps you picture future events, recall distant memories, and visualize scenes that exist only within your mind. It is the silent painter of your inner world, blending emotion, memory, and imagination into soft mental landscapes. But as night approaches, the precuneus gradually loosens its hold on conscious imagery. Visual thoughts become softer, vaguer, and more fluid, allowing the mind to drift into the open space between waking and dreaming. This shift is what creates the gentle, hypnagogic images that appear as you begin to fall asleep. Floating shapes, quiet colors, distant impressions dissolving into one another. During REM sleep, the precuneus engages again, but in a freer, more symbolic way. It collaborates with emotional and memory networks to form the vivid visual worlds of dreams. Scenes emerge without logic, shapes shift effortlessly, and the mind explores places it has never been. This nightly activation allows the brain to process emotions through imagery, giving form to feelings that might be difficult to express during the day. As you drift deeper into rest now, imagine the precuneus softly painting expansive dreamscapes. Gentle horizons, quiet rooms, drifting colors, inviting your awareness into the peaceful depth of sleep. At the core of your sense of identity lies the medial prefrontal cortex, a region that helps you reflect on yourself, your memories, your hopes, your emotions, your inner story. Throughout waking life, It carries the subtle weight of introspection. It helps you understand your motivations, your relationships, and the quiet truths that shape your choices. But as night settles in, this introspective region gently dims. The need to evaluate, to interpret, to question who you are becomes softer, lighter. The boundaries of the self begin to blur, creating space for the mind to drift without the pressure of reflection. During sleep, the medial prefrontal cortex becomes one of the calmest regions in the brain. This quieting is essential. It allows the mind to temporarily release self-focused thought, giving emotional networks room to reset and heal. Dreams sometimes bring symbolic versions of the self, exploring identity in fluid and imaginative forms, free from the constraints of waking awareness. By morning, the medial prefrontal cortex reconnects gently with the rest of the brain, offering a refreshed sense of clarity and self-understanding. As you continue descending into deeper calm, imagine this region letting go fully, allowing your inner world to drift into a peaceful, expansive silence. Deep within the brain's inner network lies the angular gyrus, a region involved in blending senses, thoughts, language, and imagination into a single, unified experience. During the day, it helps you read, interpret metaphors, understand spatial relationships, and integrate different streams of information. It is where ideas come together, where separate pieces form a coherent whole. But as night approaches, the angular gyrus slowly releases its need to organize and categorize. Meanings loosen, interpretations soften, the strict boundaries between thoughts fade. This gentle unwinding allows the mind to drift into a more fluid, dreamlike state, where imagination moves effortlessly. During sleep, the angular gyrus participates in forming the symbolic structure of dreams. It helps weave unrelated images, emotions, and memories into soft narratives that carry emotional truth more than literal meaning. It blends visuals with sensations and ideas with feelings, creating the surreal moments that feel vivid, yet strangely coherent inside dreams. As you continue sinking into the night, imagine this region relaxing, letting go of the need to interpret, to define, to understand. Allow meanings to become gentle, spacious, and open, making room for the mind to rest in quiet fluidity. Within the parietal lobe rests the superior parietal lobule, a region responsible for mapping the body in space, guiding movement, and giving you a sense of physical presence. It helps you reach, grasp, and navigate the world with quiet precision. During waking hours, it is constantly active, adjusting your awareness of posture, boundaries, and motion. But as sleep approaches, this region softens its activity. The body feels heavier, less defined, and more distant. Limbs seem lighter, boundaries blur, and the sense of physical form begins to dissolve. This gentle loss of body awareness allows deeper rest to unfold. During deep sleep, the superior parietal lobule becomes one of the quietest regions in the brain. Without the need to track movement or position, its networks fall into stillness, contributing to the floating or drifting sensations often experienced at the edge of dreams. This quieting also allows the brain to redirect energy toward physical repair. Muscles restore, tissues rebuild, and the body recalibrates. As you drift further now, imagine your physical boundaries softening completely. Your body melting into the mattress, dissolving into comfort, supported fully by the quiet around you. Deep within the brain's emotional memory network lies the parahippocampal cortex, a region that helps you navigate spaces, recall environments, and attach meaning to places. During the day, it quietly records the settings of your life, the rooms you move through, the streets you walk, the comforting spaces where you feel safe. It blends location with memory, forming a gentle map of your experiences. But as night approaches, this region gradually relaxes. The details of environments soften. The edges of places blur. The mind no longer tries to anchor itself in physical worlds, allowing inner landscapes to emerge instead. During sleep, the parahippocampal cortex participates in creating the dream environments you explore. It rearranges fragments of real places, hallways, fields, rooms, and blends them with imagination to form surreal but familiar spaces. These environments help the brain contextualize emotions, offering symbolic settings where feelings can unfold safely. As you drift deeper now, imagine your inner landscapes opening into soft, boundless spaces. Rooms without walls, streets without edges, places without pressure. Let the world around you dissolve into the spacious calm of the dream realm. Hidden near the brainstem lies the locus coeruleus, a tiny cluster of neurons responsible for releasing norepinephrine, a chemical tied to alertness, focus, and readiness. During the day, this region keeps you attentive, responsive, and aware of your surroundings. It heightens your sense of presence and supports quick reactions. But as evening approaches, the locus coeruleus gently reduces its activity. Its steady stream of alerting signals fades, allowing your nervous system to shift from vigilance into relaxation. This transition is essential. It helps the mind release tension and drift into softer states. During deep sleep, the locus coeruleus becomes almost completely silent. This silence is what allows the brain to enter dream states without reacting to imagined threats. It also gives emotional circuits the freedom to recalibrate. Without norepinephrine, dreams unfold with fluidity, and without the sharpness of daytime thought, the brain explores emotions gently, symbolically, and with a sense of safety. As you settle further into rest now, imagine this tiny cluster of neurons dimming completely. Its signals quiet, its influence resting, leaving your mind open to peace, stillness, and the gentle drift of sleep. Deep within the brain's emotional communication system lies the periaqueductal gray, a region that helps regulate fear, pain, and the instinctive responses tied to survival. During the day, it works quietly, adjusting your reactions to stress and helping you navigate moments of discomfort or threat. It is ancient, intuitive, and deeply connected to your sense of safety. But as night approaches, the periaqueductal gray softens its vigilance. Its signals become quieter, less urgent, allowing the mind to transition from protection into rest. This gentle shift opens the doorway to deeper sleep, easing the body away from tension and toward comfort. During sleep, especially during REM stages, the periaqueductal gray engages in subtle recalibration. It helps the brain process emotional memories, softening intense feelings and reducing the emotional weight carried from the day. Fear becomes symbolic. Stress loses its sharpness. The brain explores emotional themes in a safe, imagined environment, freeing you from the instinctive responses that dominate waking life. As you drift further into stillness, imagine this region relaxing, letting go of the day's intensity, releasing the need to guard, allowing emotional clarity to form beneath the surface of dreams. Resting near the brain's visual regions is the lateral occipital cortex, a structure responsible for interpreting shapes, objects, and the visual world around you. Throughout the day, it works constantly, helping you make sense of everything you see: faces, textures, shadows, and forms. It identifies patterns effortlessly, blending sight with memory to create a coherent experience of the world. But as night comes, the lateral occipital cortex gradually dims. The visual world becomes less defined, and the sharp edges of perception soften, creating a bridge between external clarity and internal imagery. During dreaming, the lateral occipital cortex activates in a new and fluid way. Instead of interpreting real-world images, it helps generate the shifting, symbolic visuals of the dream state. Shapes morph, colors blend, and familiar objects transform into imaginative variations of themselves. The brain is free to explore imagery without the constraints of physical reality. As you drift deeper now, imagine your visual cortex dimming, releasing the sharpness of sight and opening into the soft, drifting colors of your inner world. Let the last details of wakefulness fade as the gentle canvas of dreaming forms within you.